Ursula, did you get sorted with Sylvia? It's okay now, yeah? Alright, so we're still missing Juliana and...
Bear is the only one there.
She must be invisible right now?
No, she can't watch it.
Right. And Bahar, so I'll only be missing Bahar then, is it? Yeah, okay. Right, so we'll have a look at now. We kind of had a look at inequalities, but only a little bit. Inequalities mean like less than, more than, things like this. Guys, come on. Ready? Okay. Let me just start my pen. Okay. We're good. Right, so inequalities now. Can we see? Nice. Okay. So inequalities, you probably recognize the symbol. That's this one, and this one. Less than or equal to, more than or equal to. These are the four. Guys, what's wrong? Come on. Okay, so before we can start with inequalities, we just need to talk a little bit about some basic sets. So the set OR, does anyone know the name of this set of numbers? Real numbers, yes. Real numbers, yes. And what are the real numbers?
1, 2, 3.
That's some of them, yeah. More than that? Basically, yeah. Real numbers, well, they're all the numbers from minus infinity to infinity. So, all of these numbers on the number line. Okay, so the next set now is Z. Anyone know this set? Integers, and what are those? Say again? That's it. Positive and negative, or only positive? Both, yeah. So these are basically numbers like minus 3, minus 2, minus 1, 0, 1, 2, 3. So these are the integers, okay? And then the next one we'll do, although I don't have it here, but I think it's good to see why they're all together. This Q set. Irrational.
That means like decimal points, right?
No, something that you can compare from A to B plus.
It started off so well, but not quite that. Does anyone know? Huh?
You cannot write.
They are irrational. So what exactly is the definition that makes it irrational?
You can't in the form of A over B.
Say again? True, but not quite enough.
Form of A over B.
This is it. Oh, sorry, I misspoke. These are the rational numbers. Well, the irrationals is just the opposite then. So for rational numbers, they're numbers which you can write as a fraction, and then the irrational numbers, which we'll use letter I, these will be ones that you can't write as A over B, where A and B are integers. So as you were saying, square root 2 would be of this form, but somebody was saying about decimal points, is it? So like, yeah, for example, 1 over 3, is that rational or irrational? Well, rational. And of course that can be as a decimal point as well. But a number like root 2, 1.41, that is irrational because you cannot write it as a number divided by another number. Okay. Anyways, we don't need to talk much about that. That was more than enough. So for this lesson, we don't need to use rational and irrational. So don't worry about it. Okay. What is important is this set. What's this one? Natural numbers. And what numbers are those?
From 0 to 100.
No.
1.
Yeah. 1, 2, 3, etc. Do we include 0 or not?
No.
So, what are we saying? Yes or no here?
Yes. No.
Yeah.
Yes. No.
Well, the answer is maybe. The reason is different books and different countries sometimes use 0 and sometimes do not. In fact, it's not clear. So to make it clear, what usually people do is if they want to show that you're including 0, you would write a little 0 on the top. And if you want to show that you're not including 0, you put a little star on the top. So this one here would start at 0, and this one here would start at 1.
The exam today put n with a star or...
They don't. They're terrible about this. So in the exam, the author of the exam is not mindful of the fact that n is not actually clear. Some people use one and some people use another. In the exam, it's modelled off of the UK exams. So in the UK, I think we don't include 0, I think. But anyways, for the worksheet, I make it clear if you should include 0 or not. Okay. So if you want the 0, I'll write a 0 here, and if I don't, I'll write the star there. Okay. Right, can we scroll down now and look at some, well, just before we look at some examples, there's a little bit more notation. Can I scroll down? Yeah. Right, so suppose you only want part of a number line, like for example, you would like all the numbers between 1 and 2. Well, you can write it in this form. This means all the numbers between 1 and 2, including 1 and 2. So for example, you could say 1 belongs to this, 1.5 belongs to this set, 2 belongs to this set, but for example 2.1 does not belong to this set. Okay? So some people maybe have seen this before, some people have not. So this is called a closed set. Closed set.
I think I heard something different in American school.
What then?
I think it's notation.
Well, usually the word notation comes after set, so like set notation, but that's more general. This is in particular closed set, so it means you include 1 all the way to 2. Okay? And if you didn't want to include the numbers, for example, if you wanted all the numbers from 1 to 2, not including 1 and 2, you would write it like this. Well, let's use A and B instead of 1 and 2. So this is called an open set, and what this is all the numbers between A and B. All real numbers, I should say, between A and B. And this is a closed set, and this is all the numbers between A and B, including A and B. So this one is called open, and this one is closed. And in fact, you can have it open at one end and closed at the other end. So for example, this set 3 to 9, that would be all the numbers which are bigger than or equal to 3, but smaller than and not equal to 9. Yeah?
Why can't you put
Yes. I really don't like that. But in some places, they'll write the open set like this. Yeah. I think that is ugly. I don't like it at all. So I would prefer, please, if you use this for open and this for closed. Please. It'll make me feel better. Yeah?
What for open, what for closed?
This one is open and this one is closed.
You close to that open.
Oh yeah, of course, yes. We can have like open and closed. So this would be all the numbers bigger than 3 and less than or equal to 9. Yeah. Yeah.
Ah, okay.
Where I come from, like we don't use like a bracket. We just open when it's open. It's okay if I use it like that.
Is that what he was asking me?
So you
It's okay. You can use that if you really, really want to. But I would prefer this, please. At least that's what they are expecting you to do in the exam. Although I'll still give you the marks if you write it like this.
Oh.
It is no. Okay, do you have this? Yeah. And just actually to say, using it, you can actually write the real numbers as open set. The real numbers would be like this. All the numbers from minus infinity to infinity open. Yeah. As an example. So it's useful. Yeah. Let's have a look at some examples now. Do we have this?
No.
I haven't talked about sets because I kind of expect everyone to remember this from middle school. But just quick check. This is called union, and this one intersection. So we don't really use that one. We'll just be using union, where maybe we can use this sometimes, but usually what happens for these problems is you have two different answers and we just attach them together by using union then. We'll see it now when I do some examples, okay? Can I scroll down?
What do you use in place of intersection?
No, I'm just saying that most of our answers, some of the answers will have intersection in, but usually it's a union, because what happens is you have one possible answer here, another possible answer here, and you just attach them together with union.
So what about in the questions? Would they use intersection? I mean, or would they use some other notation?
Oh no. It will be like this when they use it. I'm just saying it's more. We'll be dealing with this more. Yeah. Okay. Right. Let's have a look at an example. So our first example is I tell you that x is a real number, and I want you to solve this. Okay. So this is only a simple one to get started. And you already know how to do this one. There's just one thing to be careful about. Anyways, we take the x to the left, and now we have minus 6x is less than or equal to 6. It's all normal algebra right now. But this is where you must be careful. Please do not forget. Yeah. When you divide or multiply by a negative number, the sign gets flipped around.
It's not only negative, it's positive as well.
No. Only when you multiply and divide by negatives does the sign get flipped. Okay? So what I want you to also do for practice is to write the answer as a set. So this is one way to present the answer. A second way to present the answer would be as a set. So you can say x belongs to the set of all real numbers bigger than...
It's minus 1.
Oh, sorry, of course it is. Ridiculous. Right, minus 1 to infinity. That's another way to write it. Yeah. think about it. I'll draw it on a number line for you. The third way to write the answer. So you have your number line. The question, I think, would ask maybe to represent the answer. Well, I'll get to that in a second. Minus 1, 0, 1, and this goes to infinity, and this goes to minus infinity. So look at your answer here. You want all numbers bigger than or equal to minus 1. So here's minus 1, and if you want bigger than, should I go left or right? Right, yeah. So these are the three ways to represent your answer. First as an inequality, second as a set, and third on a diagram. Okay. Now, just to be clear before we go on, if this was not equal to, then what do I change here? That would change here. And also here, you make the you make it have a hole in the middle. So this is what it would be. Yeah, for open. But that's not the case here. It's closed. So it's like this.
What difference would it make if I, instead of next to infinity, I put a proper square bracket instead of curved one?
Then that means you're including infinity, which you're not allowed. It's everything up to and less than infinity. Okay.
Question.
Yes.
Why did we change the
Inequality.
Yeah.
Good question. So, why do you flip the sign around when you multiply or divide by a negative? So, for example, here's our number line. 0, 1, 2, minus 1, minus 2. So, which is bigger between 1 and 2? Well, of course, 2. And which is bigger between minus 2 and minus 1? Minus 1. So if you have the statement 2 is more than 1, and you multiply by minus 1, and if you don't change it, you'll get minus 1. Minus 2 is more than minus 1. Now that's false, because you just said minus 1 is bigger than minus 2. So this is the reason that we have to flip it. Because here, when 2 is bigger than 1, that gets reversed if we multiply by a minus. Now the minus 1 is bigger than minus 2. So the reason we flip it is because the statement would be false if we didn't. Okay. Right, let's have a look at more examples now. Can I scroll down? Oh yeah, and just to say, please, in the exam, read the question very carefully, okay? So many students lose marks here. So, when you're reading the question, and of course they'll say something like solve, you want to look for other keywords like set. So if it says solve the inequality and give your answer as a set, which one is that? 1, 2, or 3? No, the second one. This is as a set. Yeah. If it just said solve, end of story, make your life easy and just stop at the first one. Okay? You can continue if you want, but you're making extra work for yourself. So this would just be solved by itself. Okay? And here, what might they say if they want to see this? Yeah, not graph. They might say draw, but in fact there's another verb. Not plot. You see, graph and plot and draw, they're all usually used for 2 dimensions. Now we're getting closer with show, so we could have something like show. Show on a number line, or show on a diagram. Any other verbs that mean show? Display. Display is a little too digital. Yeah. Maybe not make, something else.
Illustrate?
Illustrate, thank you, yeah. So illustrate is actually the more common verb to go with this problem. So they could say show on a number line or illustrate on a number line. Maybe display on a number line. Maybe. Any other? Huh? No. No. Right, so before moving on, I'll just say it one more time. In the exam, don't lose a mark just because you didn't fully read the question. It's very, very common for students to forget to do this and just stop here, and you lose 1 mark if the question said, give your answer as a set. Okay, so don't lose this 1 mark, it's not necessary. Yeah?
Is it academic or not academic? Is it okay to show it like that, like the scribble on the...
Yeah. It's something to highlight it. Like in your red pen or something. Look, if you did this, you'll get the mark. Yeah? It's not an art competition, okay? Once I can understand it, it's fine. Right. Let's try another example now. We'll make it a little bit more difficult. Yeah? Question? Yeah. Wait, hang on. She can ask me. Go. The square one and the open one, what's the difference? Okay. So just the difference is, for example, if I write this, let's say 1 to 10. This means all the numbers from 1 to 10, including 1 and 10. Whereas if I write this, it means all the numbers from 1 to 10, not including 1 and 10. So like 1.1. So like if I write closed and open like this, all the numbers from 1 to 10, including 1, but not including 10. Yeah, and then finally the only other possibility is like this.
That's confusing.
Deal with it. Yeah. So this one here, 1 to 10. Yes. Is that okay now?
What we got next, like the last question?
Hang on. Stop. I'm going to the next example. I've spent too much time on the last one. If you don't understand something, we can bring it up in the tutorial. But I need to go on with more examples. Right, so for this example, I'm saying x is a natural number. Include 0 or do not include 0? Do not include 0. And what's a little bit different here is that it's double inequality, which doesn't make it that much more difficult, but not as easy as the last one. So how could we deal with the 2 inequalities? What's an idea? One way is to do each one separately. Okay, so that's how I'll do it. But there is another way which I prefer for the exam, but I'll do it separately first. But there is another way. So the first thing you do is you split them into 2. And then this one here. Now, this is actually important. There is a big difference between this and this. And that's especially important for this lesson, okay? So when we say and, we want both of them to be true at the same time. But when we say or, we can have either true. They don't both need to be true, okay? So here, between these two, is it an and or is it an or? It's an and. Because remember, I want all of this to be true, which means each part must be true at the same time. Okay, so it's an and here for this. Now, that's important, because previously, when we had problems with 2 answers, when you had your quadratic, and we had x equals and x equals, is that an and or an or? It's an or. It can't be an and, because if it was an and, you would say x equals 1 and x equals 2 is impossible. It can't both be 1 and 2. It can be 1 or 2. Whereas here it is an and. We want both to be true. Okay, so solving this, we get 4x less than or equal to 16. So x is less than or equal to 4. And here we get, if I bring that over there and bring this over there, 8, is it minus 8 less than or equal to 4x? Is that right? If I took that, yeah. Well, I took the 13 to the left. 5 minus 13 is minus 8, and that comes to the right to make plus. So if I divide by 4, I'll get minus 2 is bigger than or equal to x. No?
You change the sign.
Yeah, because I divided by 4. Like this, yes. Or, what I was wanting to say is x is bigger than or equal to minus 2. It's the same thing, yeah.
So even if you just move the 5 to this side and you leave the minus 4x there, you still get the same.
Oh yes, yeah. If you, what were we saying? Leave the 5 here?
You move the 5 to the other side and you leave the
Oh yeah, and bring the 5 to the other side. Yeah, you'll get minus 4x less than or equal to 8. And what will happen is when you divide by the minus 4, it'll flip around then. Now, we're not quite finished because we have to remember there's an and between them. So, it's really helpful to draw the number line here. Yep. So we have here minus 2, 0 and 4. My first answer I'll draw in red. So x is less than or equal to 4. So, you got the idea. And in blue is the second answer. X is bigger than or equal to minus 2. So that's everything here. I'll put it on top actually. Now, you want and. So that means you want both to be true at the same time. And the only way both red and blue can be true at the same time is here to here. So your final answer is x must be bigger than or equal to minus 2 and smaller than or equal to 4. That gives us the and. Now that's not actually finished. There's still one thing left to do. I wonder if anyone remembers in the question. Yeah, the set. So what's the set here? Minus 2 bracket 4. No. 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 Yes, go on. No, you're right, go on. The minus is a problem. Yeah. You need to remember, at the very, very start of the question, I said x is a natural number. So the answer is too big here. I'm including numbers I shouldn't include. X is a natural number not including 0. So think about this. The natural numbers not including 0 between minus 2 and 4. What are those numbers? 1, 2, 3 and 4. So this is actually the final answer.
And do we write like
the curly brackets here, yeah. At the very start I said x is a natural number. And it can't be decimals. Yeah. So if you gave the answer like this, you wouldn't be right.
curly? That's the first time.
Oh, that just means you're listing the numbers.
So we don't have to write like square or...
No. You want to make it different to square and circle.
And would it be enough?
This one? Yeah, it's not finished. Because you're not allowed to use negative numbers. I said x is a natural number. So this answer is too big. This is actually the right answer. Yeah. Okay, did you write that down? Yep. Yes. Shh. I can't hear her. If they ask us to solve. Yeah, if they just said solve and they didn't say anything about x, yeah, then you can assume x is a real number, and so you can stop here. If x is a natural number, then you can't stop here because, well, these are definitely not natural numbers, so your answer is wrong then. You have to use this fact as well, yeah.
Well, we don't have to draw the
No. Oh, I only drew this to help explain how to combine the answers, yeah. In fact, you don't need to do this. It just helps to visualize. Yeah.
If we did this in exam, would it be correct?
Yeah, this is all fine.
Can we just write 1 comma 4 in the square bracket instead of 1 to 6?
1 comma 4, and what brackets here? Yeah, so why is that wrong? Why am I not doing that? Yeah. 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 This is all the numbers between 1 and 4, including numbers like 1.1, 1.2, 1.3. Whereas this is only those natural numbers. Yeah. Okay, I said there's a second way to do this one. I'm going to do this one again using the other method. Can I scroll down? Yes. Okay. So let me just rewrite the question again. Minus 11. So example, same example. Minus 11 less than or equal to minus 4x plus 5 less than or equal to 13. Okay, so the second way to do this one, which is kind of the way they would expect you to do it in the exam, it's much quicker. You want to cancel the cancel the 5. So the way you cancel the 5 is by putting a minus 5 on all three parts. So then this and this will cancel. So now we have minus 16 less than or equal to minus 4x less than or equal to 8. Now, to cancel the minus 4, divide everything by minus 4. So this becomes minus 2, this becomes x, and this becomes 4. And remembering that minus changes this one. So in other words, you get x must be bigger than minus 2 and less than or equal to 4. And you remember that x must be a natural number, not including 0. So then the only possibilities are 1, 2, 3, and 4 as the final answer. Okay, so you can see that this method is much quicker to do. And this is really what they expect you to do in the exam. Yeah.
What did you change the sign again?
Because I divided by minus 4.
So that changes that.
That changed it around, yeah. Okay, continue. Yep. Okay, let's zoom out a bit. Right, so far, all the examples we've done have all been linear, which, it's not so difficult. We'll have a look now at a quadratic example. So we'll say 21 x squared plus 32 x plus 12 is greater than or equal to 0. Again, there's two ways to do these ones, okay? So, let's just take the calculator here for a second. What I used to do is I used to show students one way of doing it, and then when they find out there's a second way and they see the second way, they said, why didn't you show us the second way? That was easier. So then the next year I would show the students the second way of doing it, and then they said there's another way, and I showed them the first way and said, why didn't you show us the first way? That was easier. So I'm going to show you both ways and you decide which one's easier, okay? So the first way we'll have to factorize. So I'll get the calculator to help. Oh yeah, sorry, I also forgot to say that x is a natural number including 0. Okay, right. So we have 3x plus 2, 7x plus 6, greater than or equal to 0. Okay, so the first way of doing it, by factorizing, okay?
the exam.
If you have, in the exam they won't care which method you use for this type of problem, it's fine. But I would think the second method is what I would use in the exam, but I'm showing you the first method anyways. Okay, so, you have two numbers which are multiplied together and they will be positive. There's only two ways that that can happen. Let me just make a bit more space here. The first way is if each of them are positive. So the first way is that 3x plus 2 is positive and 7x plus 6 is positive. That's one way you can make, I just squeeze that in a bit better, and 7x plus 6 is positive. That's one way two numbers could be positive when they're multiplied. The second way would be what? They're both negative. And 7x plus 6 is also negative. Okay? So if I want this to be positive, I need both of them to be positive or both of them to be negative. That's the only way this could be positive. There's no other possibility. Okay? So now what I've done is I've taken my one quadratic problem and really I've made it into four simple linear problems which you can solve in your head. So this one here is x must be bigger than or equal to minus 2 over 3 and x must be bigger than or equal to minus 6 over 7 or x must be smaller than or equal to minus 2 over 3 and x must be smaller than or equal to minus 6 over 7. We need to combine our answers now, so I'll just give you a second to write this down because the next part we're putting all four together and I want your full attention. So if we can write this much down. Okay? So anyways, I'll continue it here. What I'll do first is I'll do a very rough number line. So minus 6 over 7 would be here, and minus 2 over 3 would be here, and then over here again, minus 6 over 7 will be here, and minus 2 over 3 will be here. So in the first one we have and. So in red and blue, x must be bigger than or equal to minus 2 over 3, so it must be here. And in blue, x must be bigger than minus 6 over 7, so that's here in blue. So, in the first box here, if I want both to be true with the and, what's my final answer here? What's the only way both can be true? Yeah, the only way both can be true is if x is bigger than or equal to minus 2 over 3. That's the only way to have both at the same time. Likewise here, in red, x must be smaller than minus 2 over 3. And x must be smaller than minus 6 over 7. And the only way I can have both if x is smaller than minus 6 over 7. Now what combines these answers? An or. So we have x is bigger than or equal to minus 2 over 3 or x is smaller than or equal to minus 6 over 7. So let me put that now on the number line. Minus 6 over 7 minus 2 over 3. So the first one is this one. This one. And then this one here. So to finish, I want to give the answer as a set. So what would be this set here? Yeah, from minus infinity to minus 6 over 7. Closed or open? Closed. And this set? Closed minus 2 over 3 to infinity. And we stick the two answers together with union. Okay.
So if it's closed, we don't include that number, right?
No, if it's closed, you do include it.
And if
If it's open, you don't include it.
Oh.
Yeah. Now, right now, you should be thinking, I wonder if this is the easy method or the hard method.
The hardest.
You know, it is. Yeah, it's a hard one, yeah. So I'll show you the much easier way to do it next. Yeah. So the easy way. The easy way is you solve your quadratic and put your roots on the number line. So here is minus 2 over 3 and here is minus 6 over 7. You draw the quadratic, and if you have positive, you look at the piece which is above the y-axis, and if you have negative, you look at the piece which is below. So am I looking above or below? Above. So here and here, yes? So that's this piece and this piece. So that's x is less than or equal to minus 6 over 7, or x is bigger than or equal to minus 2 over 3. The exact same result. But because you saw the difficult way of doing it, you can now appreciate this is the best way to do it in the exam. Yes? Now, of course, I'm not finished, but the last piece is the same. Yeah? Oh, a very rough sketch. Like, the only two things that matter for the sketch is you get the correct root and you draw it either as a U shape or as the hill shape. Yeah, because if I drew it as the hill shape, it would be a different answer. For example, if I drew it as a hill shape and I wanted positive, that means I'd want this piece, and the answer would be between the two numbers. Whereas here, the positive is here and here, so I want the answer outside the two numbers.
A is positive and 5 is minus.
Yes, yes. Okay. I have one more example to do. We'll get the technical term later in the semester, yeah. I think convex. Yes. Okay. Yes. Oh, sorry, I forgot about the natural number part. Thank you for reminding me. So there's one more step. We said that x is a natural number. So the very last step, what are the natural numbers in this step? Did I say to include 0? I did? Yeah. So 0. 1, 2. Yeah. Because the natural numbers would be over here at 0, wouldn't they? So in fact, it's going to be all of them, isn't it? I don't stop. No limit. Yeah. Yeah, that's quite unusual actually, because usually in the exam there'd be some reason for you to stop, but in this one there wasn't, so. Okay. No, do it this way. I'm just showing you the two ways to do it. Yeah? Okay, I have one more example to show you. Did I say it was a natural number? Ah, okay. Yeah. Just so you know, listen, in this question here, I said x is a natural number, but in the worksheet I said it was a real number. So if you see this question in the worksheet, you would have stopped here, but for my example I stopped here. Okay, I have one more example to show you. Because of the time, I'm not going to finish the example. I'm just going to do enough of it so that it becomes one of the problems we've seen earlier today. Okay, so I'll show you how to simplify it then. Scrolling down. Well, actually, you know what? It's actually not too long to do. 71 less than or equal to 2x squared plus 20x plus 49 less than or equal to 97. Less talking, more writing. Come on. Right, so what we have... come on. We have a quadratic and two inequalities. What? Because, you know, maths. Right. So we only have one method here. We don't have two methods. In the previous version of this, we had two ways we could do it, but for this problem, there's only the one way to do it, which is to split it into two problems. 71 less than or equal to 2x squared plus 20x plus 49. 2x squared plus 20x plus 49 less than or equal to 97. So here we have 2x squared plus 20x, and then 49 minus 71 is 22, bigger than or equal to 0. And this one here, 2x squared plus 20x, and then 49 minus 97 is minus 48, less than or equal to 0. So you know what, actually I will get it finished, because I'm going to use the quick method on these two. I'll use my calculator to give me the answers. So here I have two answers, 1 and minus 11. Do I want the piece which is above or below the quadratic? Above. So I want this piece and this piece here. Now looking at the other one, I have two answers again. One answer is 2, and the second answer is minus 12. And which part am I looking at now? Below. So I have this piece. So here, I want x to be, if I put on the number line, well, yeah, I'll put on the number line. What's between these two? And or? Between these two answers? No, and. Yeah. Okay. So, minus 12, minus 11, listen, 1 and 2. So let's do this one first in blue. There's minus 11. And then bigger than 1, there it is there. And then in red, there is bigger than minus 12, but less than 2. Now I want and, so I want both of them to be true. So where does that happen, where both are true?
Below minus 11.
Yeah, below minus 11, but bigger than minus 12, and
above minus 12.
yeah, between 1 and 2. However, I also tell you something about the x. What did I tell you at the start? It's a natural number including 0, so I can forget about this. So what are the natural numbers including 0, which are between 1 and 2, including 1 and 2? 0 is not between 1 and 2. Try again.
1.5.
Natural numbers, 1 and 2. So this is the answer here for this one. So only the numbers 1 and 2 satisfy this inequality. Okay, so now this is the most difficult example on the worksheet, okay? The first, question 1 and 2 are for babies, and the rest are more difficult. Smart babies, true, but still, for babies. Right, so your homework, B and C for each. B and C. Okay? B and C for each, okay?
Yeah.
Great.